Welcome to Carlton's Math Corner. Today we're going to continue our study on scatterplots. At this time, please make sure that you have your math journal, your vocab packet, as well as something to write with. Our target today is I can use a line of fit to make predictions. Okay, so looking at the first example that we have, we have a scatterplot down here, and it looks like this scatterplot has to do with hits and runs. And these points have been plotted for us. And actually, the line of best fit was chosen. And here is the equation for that line. And my question is, what do you think would happen if we went off the graph and basically I asked you how many runs would occur with 15 hits? So if these are hits on the bottom, notice it only goes up to 10. So we're going to make a prediction. What do you think would happen at 15? Could we figure out approximately, because scatterplots, they don't go in a perfect straight line, and so we can't say for sure, but can we predict about how many runs? Well, in the last video, we drew a line of best fit, and then we figured out, in slope-intercept form, we figured out what the equation was for that line. And once we figure out the equation, could we figure out, could we use this equation to figure out how many runs it would take, or we would get, if we had 15 hits? Sure we could. Well, down here on this order, or on this coordinate plane, remember this is called the x-axis, this is called the y-axis. Okay, so the x-axis is the number of hits, the y-axis is the number of runs. So if I wanted to figure out number of runs, and I know that there's 15 hits, well, couldn't I, so if I add 15 here, couldn't I take this 15 and plug it in for x? Isn't 15 x coordinate? Yes, actually it is, because hits are x's, runs are y's. And so I could take that 15, I could plug it in for x, and so what I would get is I would have 1 times 15 minus 1. And what would you get? Exactly, we would get 14. So that means approximately we would get 14 runs with 15 hits. Okay, now remember this is approximately because scatterplots are not, there's just no guarantee. It's not a constant rate of change. There's not a perfectly straight line. And so, this is about the number, this is approximately the number of runs with 15 hits. Okay, let's look at another one. So we have exam scores here and the number of missed classes. And I want you to notice, if we draw a line of best fit, what kind of correlation would this be? Well, about right there. And I'm going to make this actually a little bit smaller. Okay, so it looks like it's a negative correlation. And, it's a moderate negative correlation. The points are pretty close to each other, but not, super duper close, but they're pretty close. So as the number of classes increase, it looks like exam scores decrease. So if you miss too many classes, your scores are probably going to decrease. Okay, and that's what this scatter plot is showing us. Now, could we determine about, what your score would be if you missed 30 classes? we could try to figure this out. Okay, so let's take and figure out, first of all, if we draw a line of best fit. Okay, so let's say it's about, I'm trying to find a place that we could put this that would, let's say it's about right, sure, about right there, around there. Okay, so if we choose a couple points, let's say we choose this point, and let's choose this point. What are the coordinates of those 2 points? Well, the first point, it looks like I have to go over, well, it's about in the middle of these two. So what number would that be? 15. And then I have to go up to about 60. Okay, so my coordinates are about 15, 60. Then how about this one? My coordinates would be over 20 and up 40. Could I determine my equation for this line of best fit? Sure I could. Well, let's do, in the last video, remember we found the slope first, so let's do that. So if I find the slope, I have to take 40 minus 60, because I got to do subtract the y coordinates first, and that is negative 20. And then I have to subtract the x coordinates, so 20 minus 15, which is 5. And negative 20 divided by 5 is negative 4. So my slope is negative 4. Okay, so now we found the slope, and now we need to find the y-intercept. So y-intercept, remember, is where does the line cross the y-axis? Now, looking at this line, if I extend this line, I want you to notice that it's, no matter what, it's going to go above the 100. And it is almost, it's almost 20 above 100. I mean, it's pretty darn close. It's, you know, maybe 15 or more. I'm gonna actually, since, I mean, this is a scatter plot, and we are estimating the exam score based on, you know, 30 missed classes. And so this is not, you know, a line that has a constant rate of change. This is a line of best fit, one that we created. So we are just estimating about where the line crosses the y-axis. And I'm going to say that it's about, you know, 115, 120, around there. And so let's use, since it's counting up by 20s, let's just go with 120. Okay, and so that means my formula in y-intercept form would be negative 4x plus 120. And so if I want to figure out what would my score be if I actually missed 30 classes, which I better have a good excuse for that, because I don't think a professor would pass you if you miss 30 classes, or, you know, a teacher in school. So let's figure this out though. If this was the case, let's plug in 30 in for x and see what our score would be. Well, if I take negative 30 plus 30, I would get negative 120 plus 120, and that means I would get 0. My score would be 0. And which makes sense. I mean, my score should not be good. especially if I miss 30 classes. And if I extend this line, I mean, it's pretty darn close to 0. It is maybe a little bit above, but not much. I mean, it's pretty darn close. So that would be my estimate, is about 0. What I want you to do is, for tomorrow, I actually want you to draw your own scatter plot. I want you to plot the hours of sleep as well as the test scores. Hours of sleep, I want you to put on the x-axis because it has to do with time, and time we always put on the x-axis because time moves forward, and so that's why we put it on the x-axis. Y-axis, we're going to put test scores, and after you plot those points, I want you to draw a line of best fit. Then, come up with the equation for that line of best fit. And I want you to determine what would your test score be after 10 hours of sleep. Okay? And remember, this is approximately, but your line of best fit and your equation should back up your approximation. Okay? Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.